the Kokoraz Educational Series is proud to present The Water Cycle! For those of you who've heard of the water cycle, you may be familiar with this image. But wait, it involves much, much more. As the name suggests, the main hero in the water cycle is water. Why, it has more powers than I do. Within a relatively small temperature range, water can change from liquid to either a solid, as ice, or a gas, as vapor, and then back again. But water, while crucial, is led by another driving force, without which all of its powers of transformation would stop in its tracks. The engine that moves it, the unsung hero behind water's fierce power, is none other than the sun! It's the sun that heats up the Earth's surface, and in turn changes ice to liquid water and liquid to vapor. While the cycle looks pretty simple and straightforward, it can really go a bunch of different directions, some of which can take thousands of years to complete. The fact is, the water cycle is continuous and constantly going on wherever we look. It's an integral part of our lives, and we couldn't do without it. It keeps plants growing, which keeps us breathing. It's why we have food to eat and access to clean water to drink. And that's why it's so important to measure and keep track of it. Since over 90% of the Earth's water is in our oceans, let's start there. Heat from the sun transforms some of the liquid on the surface of the oceans into gas, called water vapor. We call this evaporation. As evaporation occurs, it actually cools the atmosphere. And that, my friends, is evaporation! Whew, that's hard in the old vocal cords. As you know, the ocean is very salty, and when the water on its surface evaporates, it leaves the salt behind. So you can think of evaporation as a big desalinization machine. Eventually, that vapor leaving the oceans will turn back into water, and it will become potable. Potable, that means you can drink it. And how do we get from vapor back to water? The same energy from the sun that created evaporation also creates wind that moves air around the globe. As the air containing this water vapor rises, it cools, and the vapor begins to condense into clouds. This is referred to as condensation. Just as evaporation cooled the air, the process of condensation releases heat back into the atmosphere. Since the wind has moved the clouds to a new location, that heat has been redistributed across the Earth. This is one of the ways the Earth regulates its temperature. And that, my friends, is condensation! Yeah, that was a little better. These clouds can produce rain, hail, snow, or sleet. When the water falls from the atmosphere in these forms, we call it precipitation. Most precipitation falls right back into the oceans, completing the cycle. Most that falls on land gets evaporated fairly quickly. However, there is a lot of precipitation left over that can go many different directions on land. And that, my friends, is precipitation! Yeah, nailed it. But where does So where does precipitation go from there? Let's say snow falls from the atmosphere onto the ice sheets of Antarctica. Some of that snow may freeze into the ice pack. In fact, some ice has been there for hundreds of thousands of years. When water turns to ice, it can hold little bubbles of atmosphere in it, like a mini time capsule. That allows scientists to drill down into the ice and see what the atmosphere was like over 100,000 years ago. And that old ice is still in the process of the water cycle. Sticking with snow and ice for a minute, let's imagine that some fell in the winter atop a high mountain. When spring comes, the temperature gets warmer, and that same snow and ice melts into water. More water is added when it rains across the landscape. With the help of gravity, that water flows into streams and rivers. Those lead into lakes or reservoirs, and finally go back into the ocean where we started. But along the way, it does some other things too. For one, it helps shape geological features by a process we call erosion. So when you look at the Grand Canyon, it may have taken millions of years, but in part, you have the effects of the water cycle to thank for its beauty. And it's not just for beauty's sake. Rivers carry sediment across the land and into the oceans, which brings life-sustaining minerals to plants and animals. Some of the precipitation seeps into the ground in a process called infiltration. Water can travel deep into the ground between cracks in the sediment, refilling aquifers, big underground reservoirs. Some of that water we pump up and use, and some stays down there for thousands of years. But it's still part of the water cycle. The way water infiltrates soil varies depending on the kind of soil and the amount and intensity of precipitation falling in the area. And collecting precipitation data is a crucial piece to knowing how much water is available for us. The water that stays near the surface can get used up by plants and trees. It gets drawn up by the root systems and is sent up to the leaves. There, the moisture heads out of the leaves, cooling the plant off. We call this transpiration. It's kind of like plant sweat, and you guessed it, it's an enormous part of the water cycle and the water that heads back into the atmosphere. In fact, it's not just plants, but all animals take part in the water cycle too. Even you. There's a nifty term we use when we talk about the water that evaporates and the water that is transpired through plant life. And that, my friends, is evapotranspiration. Yes. We use water in a ton of different ways during the cycle. Not just to clean and drink, but to run big turbines to make electricity. Whether by rivers or infiltration, much of the water ends up back in the ocean. Only the water on the surface of the ocean evaporates, so a lot of water stays very deep for a long time. But the water in the ocean doesn't just stay in the same place. There is actually a big underwater current called the ocean conveyor belt. Or if you wanted to sound really smart, you could call it thermohaline circulation. This big underwater current goes across the entire globe, bringing cold waters to warm areas and warm waters to cold areas, taking around 1,000 to 1,500 years to complete. This ends up balancing out climate temperatures to make the Earth a more temperate place for us to live. Now that you know about the water cycle, you'll be able to see it happening wherever you look. How much precipitation do you get where you live? How does that relate to the amount of infiltration you get, or evapotranspiration? Where does the water you drink come from? Time to get out there and take a fresh look in the sky, on the ground, plants and animals around you, the weather you experience, even the many ways the water cycle shows up in your own kitchen. So from evaporation to condensation to precipitation to infiltration and evapotranspiration, you now see how the water cycle works all around us. Hey, you forgot one part! Huh? What's that? Yes. Enormous water balloons.